Hello, I'm Rocky Palumbo, and I'm joined here today with Chris Gilliard. We're going to talk about the Mimble Wimble Coin that just came out. Thanks for joining me, Chris.
Thank you, Rocky. Thanks for having me.
I first want to talk about Bitcoin maximalism a little bit, because I've heard you say you're a Bitcoin maximalist, yet you're coming out with this other coin. Now, people hear me talk about different coins, and they call me a maximalist, but I don't really like that term. I think a lot of people think it means that I like Bitcoin just because it's Bitcoin, and I hate everything else just because it's not Bitcoin. And that's not the way it is with me. I like to, give everything, its own chance, analyze everything on its own merits. And although I believe, every other coin out there is nowhere near the level where Bitcoin is right now. Bitcoin is the, it is in the NFL, right? It wins the Super Bowl only because there's no other team in the NFL, right? Everything else is down in the Pee Wee League, trying to make it into, high school ball. So what do you think about all of that? You call yourself a maximalist, yet you're doing this other coin. So how does that all fit together?
Yeah, I mean, that's the problem with labels, because people can, someone says they're a maximalist, and then this other person, and then they mean different things. So usually when I say that I kind of have a different definition of what most people consider a maximalist. And usually what I'm getting at is that I mostly agree with the things that a lot of the other coins don't have a point. And that's definitely true. But I look at it like, if you're a maximalist, you're trying to maximize the value of Bitcoin, which means that, things like airdrops and forks should to some degree be encouraged, because those are like ways that we experiment. And not only are they ways that we experiment, but they're the Bitcoin holders benefit from getting them. And I just think there's good things about the airdrops, and I've always liked them. And I've always kind of thought, well, if you're going to do an altcoin, and you want to try something, you should probably think about doing it as an airdrop. And that's mostly, what I mean by that, I guess you could say.
Okay.
Mm-hmm.
And there are two other Mimble Wimble coins out there, Grin and Beam. So why do we need a third one?
Well, so yeah, actually, when they first came out, so let me go back to like how I got interested in Mimble Wimble. So I've been in the Bitcoin space since I bought I bought a little bit in late 2013, but I mostly bought in 2014, and that's when I started paying attention. And at that point, that was well before Mimble Wimble. But then I guess in 2016, that's when the Mimble Wimble white paper came out. And I was really interested in that because it was kind of like one of the few like academic papers that talks about like a way to improve the protocol, I think. And I always put the Mimble Wimble paper up there with the Lightning Network paper, and I think those two are like the most interesting things right now, like if you're going to work on them as a developer, to me at least. And so I was like just tracking things at that point, because I still was working in 2016, and then by late 2017 I decided hey, I want to spend more time on, I wanted to take some time off first, and I did that, but I wanted to get into the Bitcoin space in development, right? Do development. I mean, my background is as a software engineer, working in Silicon Valley companies like VMware, Sun Microsystems, stuff like that. And so, like after 2017, I wanted to figure out what I was going to do. And so Mimble Wimble really interested me. So at that point, I kind of put it on hold though, because it was out there, and I was like, well, how do we do this in Bitcoin? I couldn't figure that out, and I was mostly interested in Bitcoin. But in I guess towards the end of 2018, when Grin and Beam were getting closer to launching, that kind of also rekindled my interest in it. And so I started looking into it, and I was like, well, Grin is interesting, but I don't like that there's a supply cap, and you know, I also, like I told you before, I thought that I really like the airdrops and forks because I think it gives kind of like a, how would I put it, like deference to Bitcoin holders in a sense. You're saying like, hey, we're going to try this out and we should reward the Bitcoin holders in a way. So I like that about the airdrops. And so I made a post on the GitHub for Grin saying like, have you guys considered doing like making a supply cap? And the lead developer closed my issue within like 2 hours, saying no way, like we're never, like I wish I had opened that, this is the first issue in Grin. So you know, I was like, okay, well I guess that kind of gives me a green light to go ahead and try something that I want to try. And at that point, that was around the same time I was getting in touch with like Adam Meister. I actually met Adam Meister he visited me in Puerto Rico. I mean, he went there to do some other things, but he happened to meet up with me in Puerto Rico in 2018. And like, but you know, so I got in touch with him about the idea of this project, and he thought it was a great idea. You know, he supports crypto dividends and stuff. He introduced me to Andy Hoffman right around that same time. And so things just started going, and I just decided to do it. I think that like the other thing I'd say about it, like in terms of Bitcoin maximalism, is that I really do think that there's at least a good chance that the technology we're working on will either, you know, work into Bitcoin somehow, and I don't know exactly how, but you know, like we're still very early at this point. But I see it in that way as related. Like I don't see that I'm doing something that like has no benefit to Bitcoin. It may have a benefit, it may not, but it's something that, in any case, Bitcoin's pretty big right now, right? So we should try a whole bunch of different experiments. I mean, we have enough like resources, if you want to think of it, like, you know, kind of like how a company would think of it, is like you have enough resources, let's try some other things and see what works, see what doesn't work, and maybe it'll end up being in Bitcoin someday. So that's kind of how I look at it. So yeah.
So Grin has no supply cap at all.
Correct.
And what about Beam?
Beam does have a supply cap. It's like 263 million. Beam's okay, but I guess the criticism I have of them, well, they didn't do the airdrop, and like I said, I think that's a good thing to do. But they also, you know, have kind of like a corporate structure. Like if you go to their page, they have a CEO and a CTO and all these things, and you know, they
very
got
centralized.
Yeah. So in some of the technologies they're focusing on, like they have a way where you can, like one of the features, it seems like something where they have a way where you can let someone else see all of your transactions. So like you have your privacy, but like if you want to give it to someone, and it just to me seems like it's geared towards giving it to the government somehow. And I like they could maybe enforce that with making businesses say, oh, we only want to like accept your Beam if you give your private key and let like, you know, the government see your transactions. I mean, I don't even know if I should mention this, but like I just think that that's it. It could be going in that direction, and I just, you know, I thought the Grin was like definitely the better of the two in terms of being like open source, and they kind of just really had those two flaws that I saw, and that's why, you know, hey, we want to try our own thing, and we'll see how it goes.
So what's the supply cap on Mimble Wimble Coin?
MWC has a limit of 20 million. There's only going to be 20 million ever. And
20 million.
Yeah.
But you did have the pre-mine.
Yes, we did have a pre-mine. So there's 20 million that'll ever exist. 10 million are mineable. Of the other 10 million, 6 million are airdropped to Bitcoin holders. There is 2 million that's allocated to what we call the HODL program, which is basically like a way to reward people that are holding and not selling. And then the last 2 million is for a development fund. And with that, I'll say, you know, like some people said, oh, well, why do you have a development fund? We couldn't have done it without the development fund. I mean, it would be nice. Like if you look at Grin, there was something like $100 million invested by VCs into mining hardware. And, you know, there's all these anonymous donations to developers. I would assume that if VCs invested 100 million into mining equipment for Grin, that they're also paying some of the developers. I mean, we don't know, but we do know that there's been some donations. So I guess what I would say is, like, I wish I had $1 billion or knew someone that had $1 billion that could, like, help fund us to get started, but I don't know anyone like that. So we had to do it this way.
Yeah.
Yep.
So basically you think Beam is too centralized and Grin doesn't have a good monetary policy because it's printable forever with no cap. And so you have a limited amount, but Bitcoin maximalists are going to come at you with, the pre-mine, an airdrop, right? Because these are coins that are created out of thin air, where in Bitcoin, every single coin has been worked for. It has been mined. Hardware was purchased, or in the early day, of course, it's CPU mined, so you already had the hardware, but you still spent electricity. You still committed that computer to doing all the computations to mine a block, which of course would take up 100% of your processor. So you're committing the computer to that and burning extra electricity to do it. So every coin in Bitcoin was worked for. There was work done.
Yeah.
And so this, having the smaller cap is possibly a better monetary policy, but printing coins out of thin air is not, they're going to say, right?
Yeah.
How would you answer that?
I would just say, well, like I said, we couldn't have done it without doing that, because, like, the people that were working on the project, you have to motivate them somehow, right? And we've been working on it for a year without we haven't gotten any funding, and so everyone working on it wanted to, they're going to have some upside for it, and then we're going to use it for development for other stuff after we launch as well. So I mean, we've launched now, but so we're using basically. I don't think we could have done it without that. And
so basically, it's to help pay the developers, of course, and to get users interested in it, right? Because if you're going to test the system, you need users to make transactions, right? And how do you bring those users in? You give it away free to Bitcoin users.
Well, that's the other thing about the airdrop is, like, one of the reasons we want to do the airdrop is because, like you said, the whole proof of work with Bitcoin. So we know that all those coins were earned. So we give it as an airdrop to the Bitcoin holders, and then that, like you said, it gets you your users as well. So it's kind of, it's an experiment. We'll see how it goes. Yeah.
Okay. Mm-hmm. All right. So on other interviews, I've heard you say that there's no addresses in Mimble Wimble. So, wow, how do I get somebody to send me a coin if because I'm so used to Bitcoin and even the other altcoins, there's always addresses. So how do you send this stuff or hold it without an address?
Sure. So there are no addresses in what you could call the base layer. So if you go on the Block Explorer and stuff like that, you won't see any addresses. But there are abstractions of, I'm calling it like a second layer solution, where you can put addresses on top of it. And also you can send it as files. So even if you didn't want to use this address abstraction, there's a process where, like, I could send you a file, you receive the file, and then you send it back to me and I finalize it. And that's one way you could do it. But the address abstraction that we're using, so what we did with that was, initially we took, in Grin, there's a program called Grinbox, and it's basically like a abstraction of addresses on top of Grin, so that essentially it uses a message queue, and you're able to use that message queue, and both parties in the transaction will get an address that's only known to them and the operator of the Grinbox server, and they send it back and forth. So we took Grinbox, but we found a number of issues with Grinbox, and we basically rewrote it. Probably the most important issue with it was that on Windows, it doesn't use SSL. So in Grin, if you use Grinbox, you're sending you're not sending like your private keys over clear text or anything like that, but in Grin, you're sending the transaction data over clear text without using SSL. So we started off, we were just going to try to solve that problem and implement SSL in MWC for MWC. We were calling it MWC MQ. But we found that basically we just ended up rewriting the whole thing. So we have our own basic implementation of this message queue system that gives you addresses in MWC. Does that make sense?
Kind of. So you're using this message system to send it around, but like, how is it held in the wallet? How does that wallet, how is it associated to, like if I have a wallet with one MWC in it, how is that held there?
Sure, good question. So, oh, and one thing I'll say, we were talking about this off air before. I'm not a cryptographer. So my experience is mostly, you know, I worked on a lot of like highly scalable systems, and you know, I've had a pretty long career in software engineering, but I'm not a cryptographer. You know, we use libraries, and one of the other developers is a little bit more into cryptography on the team. But you know, so I'll answer these questions the best I can. But if we get too deep into the math, you know, I'm not a cryptographer, so I'm just putting that disclaimer out there. So basically, though, Mimble Wimble, the way it works is, so you have a seed, just like in Bitcoin, you can actually have an address, which is just associated with a private key, right? But in Mimble Wimble, you don't really have that. What you do is you have a seed. It's like a BIP38 or BIP39 seed in Bitcoin, basically same thing. And that seed will generate you, I mean, I guess kind of like in Bitcoin, it generates you private keys. And the private key, each one can be associated with an output. But in Bitcoin, you can have like more than one outputs in a single address. In Mimble Wimble, you just have, you don't have the concept of address, you just have outputs. So each private key has its own output. And along with there being an output, it has an amount that can only be known to you if you have the private key. So it's a little bit complicated, but like, I don't know if that kind of clears it up. But
so can I think of this output as a UTXO equivalent in
yes.
Bitcoin?
It is that. It's like in the UTXO unspent transaction output, and in Mimble Wimble, same thing. It's unspent transaction output, but you can also have spent transaction outputs in Bitcoin or in Mimble Wimble. So yeah, it's kind of like that.
Okay, so there's no addresses, but there's a private key with outputs.
Yeah, well, each private key will have one output associated.
One output.
Yeah. Mm-hmm.
So if I received a Mimble Wimble coin and then received another one, it would go into that same output?
No, that you'd create a new output.
It would be a new output for the same key.
No, a different key.
It would be a different private key.
Yeah, that's why you have the BIP 39 seed, so you can generate as many private keys as you need. And every time you do a new transaction, or actually every output, typically you get one output in the transaction if you're the receiver. So you just increment, you get a new private key each time, and you create the new output. But if you're the sender, you create a new output as your change address too. So like it's a new private key each time, basically, for every output. Yeah.
Okay. All right. So let's look at kind of a bigger picture, like how Mimble Wimble works overall. So I'll give you an example by doing like the life of a transaction in Bitcoin, right?
Sure.
So I want to send you a Bitcoin, right? So I get my my phone wallet here. I bring up Bitcoin. I get your address. You know, you can show it to me on the screen here, and I can scan the QR code, or you could text me the address in Bitcoin. Mm-hmm. I put it in as the output. I put in there, I want to send you a Bitcoin. Then that wallet on my phone will generate the transaction. It'll take as many UTXOs and as many addresses needed to get up to that one Bitcoin or more, and then it would send one Bitcoin to your address, and anything left over would go to another address that's changed back to me, and anything left over out of that goes to the miners, right? And so it generates this address, which gets broadcast to the network, or it generates this transaction that gets broadcast to the network. And, you know, of course, it goes into the mempool. Then a miner picks it up and puts it into a block and tries to mine that block. Now in that block, there's a header, right? And in there, there's specific information like the block height and the date and the hash of the previous block. And so it will hash that. And if it's within the limits of the difficulty, you know, it wins the block, then it adds that block to the blockchain. And that block is cryptographically linked to the previous block because it has the hash of the previous block in it. So because they're cryptographically linked, hence blockchain, right? And so now you have this blockchain that's immutable, because if you change anything in that list, the hash would change. And if the hash changes, then it would change the hash in the next block, which would then have to be rehashed, and you'd have to do all this work over again. Mm-hmm. So that's in a nutshell how Bitcoin works, more or less. So how does Mimble Wimble work, more or less?
Okay, it's close to that. Like most of those things, like where you talked about with the hash and the difficulty, all that stuff is all the same. Let's see. So the difference would be that, well, there's a couple things. Let's see. So when you do the send, since there's no addresses like we talked about before, you're basically signing. You prove that you control the outputs. That, like, you do the same thing where you select a certain number of outputs. Like, let's say I'm sending 10 and I have an output with 5 and an output with 6. You know,
yes, I think I left that out when I was doing my example. As it was collecting the UTXOs and the addresses associated, there's also a signature that needs to go there to prove that you have the private key. I think I left that out.
Right. So you take, so like in Mimble Wimble, since there's no addresses, there's just outputs like we talked about in the last step. It was, so you're going to pick the outputs that give you enough. Like if you need to send 10, you pick a 5 and a 6, and you got enough to cover the fees as well. And then you have to sign for each output, which in Bitcoin, that would correspond to, I guess, you do that at the address level. And in Mimble Wimble, you have to do it at the output level because each output has a separate private key. And then, you know, as a sender, you create your change address, much like Bitcoin. But your change address is not, well, it's not, sorry, I shouldn't say address. I should say output, your change output. And you, your change output, you know, it's created similar to the way the receiver creates their receive output. So like most transactions have, you know, some number of inputs, which inputs are all just old outputs. And so, and then the receiver gets an output and the sender gets a change output. And that's what most transactions look like. And basically what happens, the difference is, like in Bitcoin, you don't have to have the receiver sign or do anything because you're just sending it to some address, right? They have to later sign and prove that they control the address. But in Mimble Wimble, you have to create what they call a slate. And the slate has this data on it with the outputs. And so the sender creates a slate. They put their change address output, and you know, they give that, and then the recipient has to get the slate and sign it, and put the output that they want it to go to in the slate, and sign, prove that they can actually they do a signature, and then it goes back to the sender who finalizes it to do the final signature, and then it's submitted to the network. So there's a little bit more steps because there's no addresses. So the recipient has to kind of like coordinate with you to tell you like which output is it going to go to.
Right. Okay, so that's like constructing the transaction. And yeah. So then does this transaction then go into some kind of mempool where it waits for a miner to pick it up?
Yes, there's a mempool. There's all those structures are still the same. And so once you've built the transaction, it goes to the network, and a miner, just like in Bitcoin, it can choose to either put it in the block or not put it in the block.
Right. And so if the fee's high enough, they're going to want to put it in.
Of course, yeah.
And so then they're going to mine that block.
Yep.
And so now, is there a hash of the previous block that gets put in the header to link it, like in Bitcoin?
Yeah, exactly. And so the place where you can, like, you may, the other thing, you know, I talk about, like you say, with Mimble Wimble, no addresses, no amounts, and you can delete the old blocks. Well, some of the data from blocks, right? The so basically, you only need to keep the unspent transaction outputs to validate transactions. So you have to keep all the headers though, because that includes data about like how many coins were created. That's all in what's called the kernels. But you can delete some of the old data. Like when you sync a node, you actually just say, give me all the outputs that are unspent. But you get all the headers and you get all the outputs.
So you're not downloading and verifying from the Genesis block. Like in a Bitcoin node, when you first fire it up and go to sync a node, it if it's a full verifying node, not a full archival node, it will still download every block from block 0 and verify each block, but then it will delete it, up until however much you want to actually save. You could set that, in the config file, how far back you want to save. But it's still a full validating node.
Yes, but you can still fully validate even though you haven't downloaded all the blocks.
In Mimble Wimble.
Yeah, in Mimble Wimble, yes.
Not in Bitcoin, you can't do that.
Correct. Yeah, and I mean that's one of the big breakthroughs essentially, like because basically what it comes down to. So and I think you might ask this later, but like we can get into the whole how do you know that there's not more coins created and stuff.
If there was a inflation bug.
Yeah. Oh, so what is the thing about inflation bug? So there could be an inflation bug in Bitcoin as well, or Mimble Wimble. Some people say it might be easier to see, but I think it would be it probably, like, if you're just looking at the blockchain, you wouldn't really notice it right away, whether it's in Mimble Wimble or Bitcoin. You have to have a computer to analyze it. So maybe the computer program that analyzes if there's an inflation bug in Bitcoin is easier, but that's really what a full node is. A full node, whether it's in Bitcoin or Mimble Wimble, what it's doing all the time is it's basically like trying to figure out if there's inflation, or it's keeping track of the inflation. I mean, that's one of the things that it does essentially.
Okay, but if I fire up a brand new Mimble Wimble node, it doesn't download every block from the Genesis block. It only gets the current UTXO set.
Yeah.
Right?
Yes.
So now there's a lot of trust involved there, because in Bitcoin, it's like, it's the big thing is don't trust, verify, right? So that's why every single node doesn't trust the nodes that it's coming from, that it's getting the correct information. It verifies everything. Like when I talked about the life of a transaction in Bitcoin, when it broadcasts that transaction and it goes to the first node, that node verifies that that's a valid transaction, right? And then it propagates that transaction to 10 or so other nodes. And each one of those nodes doesn't say, okay, you're giving me this transaction, so it's valid. No. It says, you're giving me this transaction, I'm going to validate, make sure it's a valid transaction, then put it in my mempool, and then propagate it to 10 more nodes. And each node does that because each node doesn't trust the other node, because, don't trust, verify. And
so but you're not trusting. No. So what you really want to know though, so in Bitcoin, what you care about is that there's 21 million or there's 18 million right now, right? That's the thing that you care about, right? So the way that Mimble Wimble does that is that each transaction, so you don't know the amounts. So what you do know, there's this concept in cryptography called homomorphic encryption. So basically what it does is, so if I have A plus B and it equals C, there's some cryptographic functions that let you encrypt A and encrypt B, and then you get C encrypted. And therefore, I can decrypt C and I know that it's 10. And so I know A and B, I don't know what they are, but I know they're encrypted, but I know if I decrypted them, they would add up to 10, right? So with that property, that's the basic property that Mimble Wimble uses, right? So I can add up all of the outputs that are unspent, and I don't know what amount is in each output, but I know that when I add them all up, they add up to 10 million, for instance, or 12, whatever it's supposed to be at that block height. Each block is 2.38 more than the previous one with the block reward. So what the full node does is, and they call that the kernel excess. So basically, like, that all of these outputs, I don't know how much is in each output, but I know that they add up to 10 million at the beginning, and then the next block we add a new Coinbase output, and I can add that up, and now I know that all of these outputs add up to 10 million 2.38, and then 10 million 4.6 or 0.7, whatever it adds up to.
So a new node firing up, it knows like what was in the pre-mine and what block it's currently on, and could do the math of how many coins have been created, in all the previous blocks.
Yes.
And then cryptographically know that all the UTXOs add up to that number that it should be.
Exactly. And the Genesis block, it just has one output like all the others, and that includes like all the stuff we talked about, the dev fund and all those things. And so it just has a single output, and then you add on the first block, you'll have the block number 1 had a Coinbase of 2.38. So basically what it did, that's at block number 1, the full nodes, they got the first block, and they said, okay, well, we know that the encrypted value for the first output and the encrypted value for the output in block 1, and it adds up to some encrypted value. When we decrypt it, it's 10 million 2.38, and that's what happens at every block, basically. So that's why when you have the UTXO set, you can cryptographically prove the amount of coins that are there, because all of the outputs that are considered valid on the network.
Okay. So are all nodes in Mimble Wimble created equal? Because you said something about some nodes will archive more than others.
You can set your node to be an archival node, and basically what that means, like by default, if you don't make your node an archival node, it will delete block data that it doesn't need. Because like we talked about, to validate, all you need is all the UTXOs and the header information, because that includes like some information you need to do this calculation. So you need all the headers and all the UTXOs, but you don't need like every single transaction. So here's an example. For instance, let's say today I took an output from my wallet and I sent the entire output to you. Like either I just sent the entire thing and I got no change, or it was part of several other outputs. And then you did the same to me with whatever outputs you got there. This new output, you spent the entire output, and well, actually they're always fully spent. But let's say you spent let's say we just kept doing that back and forth, and we spent like our entire balance back and forth. Like say we had 10 and then 9.99 or whatever, and then 9.98, and we did that like 100 times. At the end of that, all we need to keep is the last output in order to validate. All you need is the last output, because those spent ones, they're no longer in this this homomorphic equation that we talked about. They're no longer needed. You only need that last output. So I don't know, does that help?
Yeah, in most situations, I guess that would be all you would need. And like in my wallet, I would see in my wallet, I haven't done a transaction yet. I have a Mimble Wimble wallet, right? But I haven't done a transaction yet. So I'm assuming I would see, history of all the transactions and how many coins were sent in my wallet. And then of course, whoever sent me those coins would see the other side of that transaction. Now, what if a third party needed to see this transaction, like maybe for insurance purposes or something, that I was trying to prove that I bought something on Bitcoin? I could just say, well, here's the transaction ID. It's public. Everyone can see it. Once you know that it's that transaction ID, everyone can see it. But Mimble Wimble, no, everything's hidden. Everything's encrypted. So now I need to give something to that insurance agent so he could see that transaction.
Yeah, that's a good question. And
but if things were deleted, how could he see that? I guess it would be the archival nodes.
No, you don't need an archival node. So if you sent that money and in your wallet, you'll have that transaction data. And well, actually, yeah, you kind of do need the archival node in a roundabout way, because in the block, if you want to do it in the block explorer, technically you could probably do it without it. But the way that you do that with MWC, and all the privacy coins have this issue, is like, how do you prove a transaction? So, and that's, you were showing me earlier, you were talking about on the block explorer how there's that verify proof button. Mm-hmm. And that's exactly what that's for. So in your wallet, like let's say I sent you one MWC, then yeah, there you go. So I'd send you one MWC in the wallet, and then there's a thing in the wallet where you can say generate proof, and the proof is generated, and you can validate it on that page. So it'll create a file for you, and like I could email you that file, or I could email anyone that file, and they could upload it into the Explorer, and it would say, yes, this is valid, and this amount was sent to this address.
Okay, so it would show the amount at that point.
Yeah. We can actually, you want me to do that? I can show you.
Okay.
Yeah. Let me do, let's see, how do I share screen here? Yeah, because we were talking about the sending coins anyways. Is your wallet ready?
My wallet? Yeah,
because I could just send you the MWC and then show you the proof afterwards if you want.
Yeah.
Okay.
So do you want me to get that thing that looks like an address that's not an address?
Yeah. I mean, it is an address. It's just not in the, like, only you and I know about it. Right. And now everyone that is watching the video knows about it.
Right, but they won't be able to see anything without, they won't be able to see the amounts without that transaction proof.
Correct.
Okay, so you want me to send that to you on what's it called? Discord.
Discord, yeah. Discord's fine. Yep.
Okay. All right.
Okay. So I'm taking that address, and I actually don't even need to put the MWC-MQ. That's optional, kind of like HTTP, right? So I'll send one, and here I'll put this address that Rocky just sent me, and I'll just click send. So it's just confirming, send one MWC to this address. I do confirm, successfully sent. You probably have something on yours?
Yes, I have a message here on my screen that says, congratulations, received one MWC.
Okay, yeah. And that's how that works. So let me show you the proof now. So what you do is you go to the transaction tab, and you can click on this generate proof button, and it'll just ask me where I want to save it. Okay, and I don't know if you can see this transaction proof that popped up, but yeah, you saw that. Okay, great. So it creates this file, and now I will have to go to share, new share, I guess we'll say. Actually, yeah, now I'll just share the whole desktop. I think that'll be easier. So now you can see my whole desktop, right?
Yes.
Okay, so let's go to Explorer. Then I'm going to go. There we go, Rocky.proof. Okay, so that's going, and there we go. So proof validation success is true. So amount sent 1.0. So, and it says what the recipient address, and then you can validate these links on the block explorer as well. Now, if I changed anything in that proof file, like let's say I changed it to that I sent you to MWC, it would, on this page, it would say proof validation success false. And we're going to make this page look a little bit better, but basically, you can take the proof, and if you change anything in it, it'll no longer be valid. Yeah, so that's kind of, and all the cryptocurrencies that are private need that, something like this. So that's how that works.
Oh, I'm sorry, you just broke up a little bit. Could you repeat that last sentence?
Oh, I was just saying all the privacy coins need some way to do that, because there's no block. You can't see the transactions in the block explorer, so you need like a way to like export the proof and be able to prove to people that you paid it. So yeah.
Right, or really somebody other than the receiver, right? Because they already have the proof, would be in their wallet. So it would be, for some reason, having to show the transaction to some third party.
Yeah, you can send it to anyone. Anyone can validate it. Yep.
Right, and that proof is only for that transaction. They wouldn't be able to see anything else in the wallet, just that one transaction.
Exactly. Yep.
Okay, so all right, so let's move on to the next question here. Well, it was really about the data, but I think the data that Mimble Wimble Coin gets rid of, but I think we've already talked about that now, because I guess it is saved on the archival nodes, but not the regular nodes.
Yeah, and the only thing you need an archival node, like why we're running the archival nodes, for instance, is we're using that for block explorer type stuff. Like if you want to, because if you didn't run it as an archival node, I wouldn't even be able to in the block explorer show you block one, because it's not saved. I wouldn't know the difficulty of it. I wouldn't know all that stuff. So it's mostly for those purposes. But for actually validating transactions, you don't need it, because like we talked about, it's all about the outputs basically.
Okay, and I had another question about the total number of coins, being validated. We already talked about that. So let's just move on. Let's just move on to my last question.
Sure.
How hard would it be to fork Bitcoin into this Mimble Wimble scheme, or method way of doing the blockchain? I've heard you on other shows talk about it. Wouldn't make any sense to do it as a side chain, right? Because you still have all the data from Bitcoin, you still have to keep. So it really doesn't help much as a side chain, other than it would give people privacy, but it wouldn't help with the scaling, I would think.
Yeah, what I'd say about the sidechain option, and this pretty much applies to extension blocks, like Litecoin is proposing to do it with extension blocks. It's similar. The issue with it is that well, first of all, like you mentioned, scalability, it doesn't improve that. It makes it worse. so if you're, I guess the only way it would make it better is if people were really basically totally living in the side, if every single transaction you did was in the side chain, yeah. And you can even calculate, it would have to be like at least 5 or 6 transactions in there before it makes sense to go into it and then come out of it. So, and if you're at that point, you're almost like, well, why didn't we just do a hard fork, or why didn't we just switch to it, right? If enough people are doing that to make a scalability improvement.
Right. So would it be possible to do it as, I guess you'd have the same issues doing it as a second layer solution like Lightning?
Yeah,
it still wouldn't solve the scalability issue, although it may give you more privacy.
Yeah, so even with the privacy, and I think, I would think that the side chains and the extension blocks, they're pretty much like layer 2, right? So it's all the same thing, I think. And with privacy, I question that it improves the privacy too, because first of all, it's still opt-in privacy. Really what I think it boils down to is it's pretty much like a coin join, right? Which we can do today. So doing Mimble Wimble as a sidechain, because what you're going to have is you're going to have some people that are going to go into this Mimble Wimble chain. But if you go, like, the problems with CoinJoin are that there's not enough people joining with you right now.
If only one or a handful of people doing it, then it's too easy to see who's doing it.
Yeah. So the same would be somewhat like if you go into the Mimble Wimble extension blocker sidechain, you'd go into it. But if like I send one Bitcoin into Mimble Wimble sidechain and then like 10 minutes later I take one out, everyone's going to kind of know, well, hey, I think I know who that was, right?
So but like you said, if you went there and lived there for a while, right? If you went into it and that was pretty much all you used, like for daily transactions to send and receive, but only used on chain for like a long-term savings program, right?
That's what it would have to be. And then you'd also have to have a lot of people use it. Because like if you have a few people that are really just living in it, then it doesn't add up to much. But like if most of the people were basically living in the Mimble Wimble sidechain all the time, it would sort of have a benefit. But to me, that's kind of like, okay, then you're pretty much like, why don't we just do it in Bitcoin if everyone's going to use it mostly, right?
So how hard would it be to fork Bitcoin over to the Mimble Wimble blockchain, right?
Yeah.
I mean, it seems like you would have to, I mean, it would be almost like ending Bitcoin and starting Bitcoin 2.0.
It could be like that. It might be like installing the UTXO set into a different program almost. I mean, that's one way to do it. I think there's a way to do it as a soft fork. I need to think about it more, but I think it could be done. But still, it would be pretty invasive. Like you'd have to switch to it. Like you'd have to basically like. So I think even if you did it as a soft fork, someone would like. If you were able to do it as a soft fork, I think someone would hard fork and go back to the old Bitcoin, right? So because I think basically there's going to be contention no matter what, and it might be that so it might be better to actually just do it as a hard fork and like do a chain split and let things roll out.
Yeah, that was my next question. It seems like technically it would be very hard to do just technically, but then you would still have to get consensus to do it, right? Otherwise you're going to fork.
I don't think you can get consensus for it. So I think if it's going to be done, it has to be done as a fork. It could be done as a soft fork, but then like I said, I think it can be done as a soft fork. I need to think about it a little bit more. But if it can be done as a soft fork, I think you're going to have someone decide to hard fork away back to the old system because it's too invasive, right? So I think either way, if it's implemented in Bitcoin, you're going to end up with a chain split. I don't see any way around it.
Mm-hmm.
And then the market has to decide, like, is this really better or is it not better?
Mm-hmm. What about, I did think of one other question that I forgot to add to my list. What about these privacy coins that some exchanges are shying away from now? Like, Coinbase never supported, even to this day, supported Monero because of the privacy on it. And governments doesn't like that, and they don't want the government to pull their license to do business, so they're not going to have Monero on their exchange, right? And there was recently an exchange somewhere overseas, I don't remember where, and there were some new regulations that came out in that area that made them decide to delist a bunch of coins, including Monero, and I think there was 5 or 6 different coins they did. Zcash and even Dash now, their private send, which used to be a feature if you wanted it, now it's every send is a private send. So that Dash got delisted from that exchange because of these privacy features. So do you see any issues with this? Coins with good privacy like Mimble Wimble not being able to trade them on any exchanges?
Well, I kind of think the governments don't really like any of the cryptocurrency anyways. They just know they kind of have to go along with like Bitcoin. I think there is to some extent, people are looking at it like, okay, well maybe Bitcoin's not as bad as some of these other things we could get somehow. I don't think the reason that they're worried about them so much is what they say. Like, I don't think it's that like they're worried that people are going to buy drugs or something like that. I think it's more that they're worried about people having financial privacy, and it's up to the people to demand that they want financial privacy or not. So it just depends upon what people want, basically.
Well, I think it's privacy and control. They don't want to give up the control. They like being able to control the money.
Exactly.
And unsound money is good for nation states, not so good for the average man.
Yeah. Well, so I think maybe what they're looking at is like, well, if we have, like, they may see the writing on the wall with, like all this money printing and stuff, that maybe someday I mean, like, I don't think it's going to happen tomorrow, but like maybe someday we're going to go away from, fiat currencies and go to something like Bitcoin. But maybe they're saying, but like, well, at least with Bitcoin right now, we can still do our KYC part of it, right? Mm-hmm. And that's so that may be one reason they kind of like favor Bitcoin over Monero and other things like Mimble Wimble Coin and Grin, and all those would be in the same boat. But I think that I don't think it really makes sense. Like, I think that it's just that they have that power right now that they shouldn't have, right? If you go back to like how, with gold, banks with gold, where they were just issuing like, certificates, gold certificates and stuff. There was like KYC is like pretty much like a new thing, right? So I think maybe, I mean, hopefully we can go back to more traditional ways of holding our money and how, I mean, because there was more financial privacy then, because each bank there was no like kind of like centralized thing. You just go to a bank and deposit your gold, I guess. So I think we want to go back towards that. Hopefully people will demand that, but we'll see what happens.
Yeah, I think the nation states are just using that privacy thing as it's really a farce, right? They're really worried about control, I think. Definitely. Because Bitcoin, at least Bitcoin, right? Not the privacy coins, but Bitcoin is very private to the average citizen, right? But it's not so private to the government, because the government has resources like FBI, CIA, these three-letter agencies that could subpoena your internet service provider for records, right? But to the average citizen, it's very private. Like if you send me a Bitcoin and then let's say I have a desktop wallet, right? And I give you an address from that and you send me a Bitcoin, then I send it from there. I send that same Bitcoin to my treasurer, right? Mm-hmm. Where is that Bitcoin? I know where it is. You don't know where it is, right? You don't know that I sent it to another wallet I control. I could have sent it to some guy who I owed 1 Bitcoin to, or I could have bought something. I wanted to pay $8,000 for it. And I sent it to a merchant to buy something for 1 Bitcoin. All you do is you see it moved. You don't know that that address is attached to me or not attached to me. You need to be a 3-letter agency to figure that out.
Well, not necessarily, right? Like there's, I mean, there's coin analysis. So company, I mean,
at this point though, coin analysis wouldn't help, right? At that point of just moving it, like if I moved it to my treasurer where I plan on keeping it for 10, 15 years, right? Okay, it doesn't move. So coin analysis isn't going to help link that address to any other address in my wallet, right? Well, okay. And if I send it to a friend who did the same thing, he sent me the address of his treasurer and I sent it to him and he hodls it for 15 years, right? Again, coin analysis isn't going to help you there.
Well, I think you're talking about you're a very sophisticated user, okay, right? Let's be frank, right? And so some of the things that you can do to avoid being tracked. But the average user, like let's talk about people that I interact with, right? Like my sister, my mother, they have a little bit of Bitcoin, and if you started telling them that kind of stuff, they're gonna be like, oh, tell Chris to do it. He'll do it for me, right? Or So I mean, I think like people. And the other thing I'd say is like you could be very sophisticated and do like a bunch of things right, to not let people know what's going on. But then you could later slip up, and that's what the whole coin analysis is about. Like you could just let me just send this one transaction. I need to do something real fast or whatever, and then you mess up like 10 years worth of like painstaking work, right?
Yes.
It's those kind of things, and I think that it wouldn't just be the FBI; it would be the like anyone that can afford to buy that data because it's public data. Like all the corporations that want to know this kind of stuff, they could pay coin analysis and just say, okay, well, who slipped up and who do you know about and stuff like that, right?
Well, coin analysis could see the coins moving and link, because of certain movements and linking to change addresses and bringing addresses together to make a payment, like a bunch of little addresses that that would then link it. But they can't. Coin analysis can't subpoena ISP records.
Oh no, yeah, of course not. Yeah, I mean, so there's some things that governments could do, but I think that there's still a lot of things that like publicly could be done. Like let's say I'm a business and if I'm a merchant and I accept a payment from you and I know which address you sent it from, I think unless you take a lot of precautions, like something like what you're talking about, I think there's a lot of data that they could get from that, and they could sell it to other people too. So like if and they will, that type of stuff will be built, right? Like because companies will share the same kind of infrastructure for accepting payments. I mean, like BitPay is an example. I don't know if they're doing this, but like if everyone's using BitPay and then BitPay knows every single time, or maybe not every single time, but like frequently they know the payments, they could start to build this profile up. So, I mean, I don't think it's like 100% one way or another, but I guess what I'm saying is like, I think particularly for like, I think it'd be nice if you just took away that whole thing. And that, like, if I go into a store and I have like my phone or my Trezor or whatever, like some hardware device that's on my phone and I pay, like it'd be nice if those things aren't linked. And with Mimble Wimble, like it's not, there's even with just things that I've dealt with, like it's like you don't have to worry about like setting up things like with your Bitcoin. You have to send it to this other, like you have another, like you said, you have another wallet that you send it into before you send it, and that kind of stuff. You don't have to worry about that. So that's kind of nice, but yeah.
Okay, great. Well, this has been an awesome talk. I've learned so much about Mimble Wimble. This is great. I can't wait for everyone else to see this video and so they can benefit from it also. Is there anything else you'd like to add, or would you like to give out information about yourself or Mimble Wimble?
Sure. So what I'll say, if you want to find out more about MWC, go to our website, mwc.mw. And from there, that's probably the best place to go because you can get our Twitter, you can get our Discord, and just get as much information from that page, Telegram as well. And that's the place to go, basically. And yeah, thank you so much for having me, Rocky. It was really good answering all these questions. I think these are great questions. So
you're welcome. Thank you for taking the time to talk with me today. I wanted to talk to you, and I thought, well, why not record it? Because I'm sure other people have these same types of questions, and we can all benefit from this discussion. But let me share my screen one last time here, and I just want to plug Just Learn Bitcoin for anyone who wants to learn anything about Bitcoin. You could go to the consulting here and get consultations on just about anything about Bitcoin. And also would like to point out on the home screen here, we are still trying to raise money for Phil. Pastor Phil was saving or buying little bits of Bitcoin for years, trying to save up a nice little savings for when he's gone to take care of his family and his daughter with a disability. So if you want to learn more about that, you can come here, and I really advise people to read this story. It's only about 3 scrolls down long. It's not that long. Just take a few minutes to read. And if you want to hear him talk about what happened to him in person, you could watch these videos here where I joined him and UK Bitcoin Master and Yes for Motivation and talked about what happened to him. And of course, please consider sending him a donation here. If you click here, it'll take you right to the tally coin where you could see, so far we got 14 donations. Every little bit counts. Send $1, send $10, send $100, or hopefully one whale will see this one day and 14 Bitcoin will be nothing to him and he'll just send 14 Bitcoin. But we can't plan on that, so every little bit counts. So in fact, you know, Chris did find out about this being on another show. And did you want to make, I think did you make this public?
Yeah. We talked like on Brian's show, he mentioned it. And
yeah, and so you're going to cover, Phil, you're going to give him the Mimble Wimble he would have received if he never lost his Bitcoin. So
yeah.
that's a really nice gesture. And I talked to him about that. He really appreciates that.
Yeah. I mean, like we saw the shows and stuff, you know, so like we figured that was like the least we could do is give him what he would have got for registering. So it's worth something for him.
Yes, and I'm going to help him set up his wallet here soon. And we're going to get you an address so that when you can send the Bitcoin or and the Bitcoin. You could send the Mimble Wimble coin.
Yep.
All right, Chris. Thank you so much.
All right. Thank you, Rocky.